simple task till others come. First problem, y equal to a cos of log x plus b sin of log x. Prove that x square d2y by dx square plus x dy by dx plus y equal to 0. If x square plus 2xy plus 3y square is equal to 1, prove that x plus 3y bracket cube d2y by dx square plus 2 equal to 0. Third, if x cube plus y cube equal to 3axy, show that y2 is equal to 2a cube xy upon ax minus y square bracket cube. So 3 problems. We can just look at them and try to solve them orally. Like y1 in the first case will be minus a sin of log x into 1 by x plus b cos of log x into 1 by x, right? That will be y1. But that 1 by x which is there, we should multiply throughout by x, and so it will become xy1 when you take it to the left hand side, or x dy by dx equal to, it will be minus a sin log x plus b cos log x. And we again go for differentiation on both sides. So it is on the left hand side xy1. So it will become xy2 or x d2y by dx square plus dy by dx, because derivative of x will be 1. And when we differentiate right hand side again, it will become minus a cos of log x into 1 by x and minus b sin of log x into 1 by x. So we multiply throughout by x, and then what will we have? X square d2y by dx square plus x dy by dx, and on the right hand side it will be minus y, and take it to the left hand side. So one can do it orally. What about the second one? It is x square plus 2xy plus 3y square. Is this correct? Yeah, is equal to 1. Now, should we differentiate it as it is? Then what it will be? 2x plus 2x dy by dx plus 2y plus 6y dy by dx equal to 0. And we will try to collect dy by dx terms and write that. Okay. And are we going to get any y into it? So yeah, y is already there because it is there in 2y also is there, and here also we are getting 6y dy by dx, because the main worry is how to get y, and then we can probably do it. What about this? It is x cube plus y cube equal to 3axy. So if we differentiate, it will be 3x square plus 3y square dy by dx equal to 3ax dy by dx plus 3ay, and then we can collect and proceed. Probably we can't go for any adjustment here. Here it happens automatically. We just continued in differentiation manner. There was no adjustment like we used to do. Okay, y2 should be written in terms of y1 or anything like that. That we can't do. These equations are in a way what we call them. These two are, there is specific word, implicit. Yeah, When we cannot separate out x in terms of y or y in terms of x, they become implicit. And so in implicit we will continue with that y and prove it. Right? Do that. How many you have completed? First was oral. Second, should I do the second one? It was 2x plus 2x dy by dx plus 2y plus 6y dy by dx equal to 0. So far so good. It directly 2 is cancelling. So we will have x plus 3y dy by dx equal to minus of x plus y. I am putting it purposely in this manner because this is giving me the hint. Right? But still this won't work. I will have to go for dy by dx equal to minus of x plus y upon x plus 3y, so that I can at least reach it is v du. X plus 3y into du is what? Into du is minus 1 minus dy by dx. Or if we are keeping the minus sign outside, fine. It is 1 plus dy by dx. So it is v du minus u dv. It will be 1 plus 3 dy by dx upon x plus 3y bracket square. It goes for substituting dy by dx into it, and that's why that 3x plus 3y, that will come down and you will have to simplify. That's the only way to get cube. So this will be minus of x plus 3y into bracket, it is 1 minus x plus y upon x plus 3y minus of x plus y into bracket 1 minus 3 into x plus y upon x plus 3y upon x plus 3y bracket square. So it is minus of x plus 3y. If you take LCM, it is x plus 3y minus x minus y, so becomes just 2y minus of x plus y, and it will be x plus 3y minus 3x minus 3y. So 3y cancels, it will be x minus 3x, so it will be minus 2x upon x plus 3y bracket cube. It can't reduce to 2, will it? Or it is resulting in this value only? It has to. It is 2xy plus 3y square plus 2x square minus 2xy. How will it reduce to 2? Minus of, it is 2xy plus 6y square plus 2x square, oh we got it, plus 2xy upon x plus 3y bracket cube. If you take 2 common from it, it becomes this value only. So it becomes ultimately minus 2 upon x plus 3y bracket cube. It gets proved. A bit lengthy, but otherwise not difficult one. looking at the, keep eye on the answer, and you know that dy by dx is not required, so you will have to substitute. Similarly, in the third problem, it will be 3x square plus 3y square dy by dx will be equal to 3ax dy by dx minus plus 3ay. And so 3 cancels. If you take it on one side, you will get y square minus ax dy by dx equal to ay minus x square. So again, this ax minus y square itself is the hint. So we write it as dy by dx equal to, it is ax minus y square, so it is ay minus x square upon y square minus ax. Adjusting minus sign, it will be x square minus ay upon ax minus y square. So I just match up with this ax minus y square. So d2y by dx square will be v du, that is 2x minus a dy by dx, minus u dv, that is a minus 2y dy by dx, whole thing upon v square. Same way, you will have to again substitute dy by dx and proceed. It will get proved automatically. We will just revise the nth derivative formulae and then proceed further. What is nth derivative of e raised to ax? Nth derivative of e raised to ax is a raised to x e raised to x. What is nth derivative of a raised to x? A raised to x into log a raised to n. Fine. What is nth derivative of sine or cos? What was it? Ax plus b, na? Yeah. A raised to n sine or cos ax plus b plus n pi by 2, right? What is nth derivative of ax plus b bracket raised to m? And now there are 3 formulae. First one says that it will be equal to 0 if n is greater than m. It will be equal to n factorial a raised to n when n is equal to m, right? And then when n is less than m, it will be m into m minus 1, etc. m minus n minus 1, right, into ax plus b raised to m minus n into a raised to n. That's it, right? Is the case when n is less than m. Fine. D raised to n of 1 upon ax plus b bracket raised to m. It was minus 1 raised to n, Yeah. Then m into m plus 1 etc. up to m plus n minus 1 or n plus 1 or n minus 1, m plus n minus 1 into a raised to n upon ax plus b raised to m plus n. Yep. Then we have nth derivative of 1 upon ax plus b, which actually follows this formula with m equal to 1, right? So it becomes minus 1 raised to n. Is it n factorial or n minus 1 factorial? Then it is n factorial into a raised to n upon ax plus b raised to n plus 1. Yep. Then what is nth derivative of log of ax plus b? It was this formula with n minus 1th derivative into a. So it becomes minus 1 raised to n minus 1 factorial upon ax plus b raised to n into a raised to n minus 1 into a. So into a raised to n. Yep. And then we have nth derivative of e raised to ax into sine of bx plus c. That was r raised to n e raised to ax sine of bx plus c plus n theta, where r is equal to under root of a square plus b square and theta equal to tan inverse of b by a. So these are the formulae which we have seen. Anything remaining? Do we have any other formula? It was 1, 2, 3, 4, 5, 6, 7, 8, I suppose. That's it. And one has to remember all these formulae. There is a few are easy actually, but if you just keep the relation, what is required, like in yesterday's problems, mainly the formulae from trigonometry, that is sine into sine, sine into sine into sine, and something like that. So you need to simplify. So we go ahead, and again yesterday we did that sine, cos, all those types. Now today we will go for the second part, and again the question is find nth derivative. And problems are: number 1, 1 upon 1 minus 5x plus 6x square. Number 2, 1 upon x cube plus 6x square plus 11x plus 6. Third, 2x plus 3 upon 5x plus 7. Fourth, it will be 1 upon x minus 1 bracket square into x minus 2. Fifth, x cube upon x minus 1 into x minus 2 is one set. Just make a note. I will tell you how to solve, not the difficult ones, but they will all reduce to only one formula, that is nth derivative of 1 upon ax plus b. That was minus 1 raised to n into n factorial into a raised to n upon ax plus b raised to n plus 1. That was the formula, right? Partial fractions is the clue. You will have to bring each one of them in this form and proceed separately. Like yesterday it was cos into cos into cos. So you got sine, cos terms separately. Here also you need to separate. So in the first case, what are the factors? It will be 1 upon 1 minus 2x into 1 minus 3x. These are the factors. Now how will you separate them into this form? Partial fractions will be required. How do you find partial fractions? A upon, right? But that we will not do. Instead we will say that, see, 1 minus 2x plus 1 minus 3x. We don't have that much time. We simply say that this will be 0 when x is half. Put x equal to half everywhere except this. So it will be 1 upon 1 minus 3 by 2. So you will directly get A. And similarly, to find numerator of 1 minus 3x, this will be 0 at x equal to 1 by 3. Put it x equal to 1 by 3 everywhere except it. And you will get it directly. Will work here. How do we factorize this? There are rules. So this is so far as the first one. For the second one, when sum of coefficients equal to 0, it will be x minus 1 is factor. And when sum of coefficients of even powers equal to coefficients of odd powers, then x plus 1 is factor. So here odd powers sum is 1 plus 11, 12, even powers sum is 12. So it is going to be x plus 1 as factor. So we write it as 1, 6, 11, 6, and we should go for synthetic division with the root, that is minus 1. Okay, so this 1 remains as it is. 1 into minus 1, it is 5. 5 into minus 1 is minus 5. 11 minus 5 is 6. 6 into minus 1 minus 6. This is 0. So remainder is 0. And so we get factors as x plus 1 into x square plus 5x plus 6. Start with 1 power less. Original it was cube, so it will be from square. And so the factors will be x plus 1, x plus 2, x plus 3. And proceed in the same manner to find numerator of. So it is actually 1 upon x plus 1 into x plus 2 into x plus 3. This should be written as something upon x plus 1. And what is that something? This will be 0 when x equal to minus 1. So it will be 1 upon minus 1 plus 2, that is 1, and minus 1 plus 3 into 2. Like that you can find all the three numerators. Use this formula. Okay, at the most minus 1 raised to n factorial, and a also might come common in this case, but not here, because here a is different. How will we do this? 2x plus 3 upon 5x plus 7. Because now you cannot factorize, both numerator and power at denominator powers are same. You will have to write it as with some adjustment. What that adjustment can be?
Denominator, numerator.
How? Tell me. So 2x plus 3. How should I write 2x plus 3? 2x plus 3 upon 5x plus 7. So what he is trying to say, it is 2 into 2 into 5x plus 7, it will become 10x then.
2 by 5.
5x plus 7 minus 3x.
You will end up with the same thing, yeah. If I write 5x plus 7 minus 3x and minus 4, so you will get this as 1, but this will still be in the same manner. So that is not going to work. Easiest way will be take 1 by 5 common. So what remains in the denominator is x plus 7 by 5. So you can write this as 2 into x plus 7 by 5. So we are okay with the denominator right now. It is same. In the numerator 2x is okay. We have 14 by 5 and we want it as 3, that is 15 by 5. It is plus 1 by 5. get it to the single coefficient, 1 as the coefficient of x. Then it can be adjusted, otherwise it becomes tough task. Got it? So I take whatever is the coefficient of x common from denominator. So it becomes x plus 7 by 5. So it was 2x. So I write it as 2 into bracket x plus 7 by 5. And what is to be adjusted is the constant. So this can ultimately be written as 1 by 5 into bracket 2 plus 1 by 5 upon x plus 7 by 5. Good enough here. 2 by 5, 1 by 5 cancels, or it might remain as 1 by 5 and denominator will be 5x plus 7. Nth derivative of this will be 0, and this we can determine. Then these two. Okay, here you will have to go with numerator of this can be found easily by putting x equal to 2. But for the second degree term over here, you will have to go with your usual procedure, assuming ax plus b as the numerator, taking LCM and finding AB. Okay, and then again you need to separate it. And here you will have to practically divide, because we can't accept any power which is equal or greater. Okay, so this is greater. So you will have to divide by the denominator. So get rid of those terms, and then there will be some term of x. I will explain these two. You complete first 3 first. It is just bring it to 1 upon ax plus b form. That's the clue. No? Okay. Anyone? Anybody has done it? Yep. For the fourth one, we will start with saying ax plus b upon x minus 1 bracket square plus x minus 2, and the numerator will be 1 upon 2 minus 1 bracket square is equal to 1 upon x minus 1 bracket square into x minus 2. So this comes out to be 1. Now when you cross multiply, if you take LCM, the numerators should match. So it becomes ax plus b into x minus 2 plus x minus 1 bracket square equal to 1. I am just equating the numerators. If you take LCM, denominator is obviously the same. So if you multiply, it will become ax square minus 2ax plus bx minus 2b plus x square minus 2x plus 1 equal to 1. Now it will be x square into bracket a plus 1 plus x into bracket minus 2a plus b minus 2 plus 1 minus 2b equal to 1. That gives us a plus 1 equal to 0, because there is no x square term. It will be minus 2a plus b minus 2 equal to 0, and 1 minus 2b equal to 1. And we come back to matrices. 3 equations, 2 unknowns should be consistent, right? But here we don't do that. We just say that this equation tells us that b should be 0. Correct? This equation tells us that a should be minus 1, and with these two values this should be satisfied. So it is minus 2, minus of minus 2 means plus 2, plus 0 minus 2 is 0. So this is verified. So a is minus 1, b is 0. Okay, so that will result in what? A is minus 1, so minus x upon x minus 1 bracket square plus 1 upon x minus 2. We want to find nth derivative of this. Now what do we do with this? Now this should be written as minus of x minus 1. So this is plus 1, minus 1 upon x minus 1 bracket square plus 1 upon x minus 2. So this ultimately comes out to be, so this becomes minus 1 upon x minus 1, and again minus 1 upon x minus 1 square plus 1 upon x minus 2. Now this you can do by formula. This also you can do by formula. What about this? Raised to m. Raised to m. Yep. Raised to m. Actually it is just n plus 1 because into 1 ही होता है, so it doesn't make much difference. So this is raised to m से करना है. That was problem 4. In problem 5, we straight away go for the division. It is x square minus 3x plus 2. आता भास कालच अथर्वनी शिव्या खाल्ल्या तू नसताना आणि हात शेजारी होता, मध्ये बोलायचं नाही मी बोलत असताना असं सांगितल्यावर, बरोबर. आज परत तू आलायस, परत तुला वेगळ्या शिव्या द्यायला लागतील. त्यापेक्षा थांब ना, इतका वेळ दिली की नाही बडबड करू, मग कर डिवाइड. हाऊ टू वी डिवाइड? Right, there will be remainder. So what's the problem? Divide. So it will be x. So it will be x cube minus 3x square plus 2x. Subtract. So minus plus minus. This cancels. You get 3x square minus 2x. So the next will be plus 3. It will be 3x square minus 9x plus 6. Subtract. So this will cancel. It will be 7x minus 6. 7x minus, right. So now you can write this equal to x plus 3 plus 7x minus 6 upon x minus 1 into x minus 2. Fine, and then go for the partial fraction. 7x plus 3 plus numerator of x minus 1, put x equal to 1 everywhere except this. So it is 7 minus 6 upon 1 minus 2 plus x minus 2. The numerator put x equal to 2. So it is 14 minus 6 upon 2 minus 1. When the power of the numerator is less than the denominator, we can use this formula directly. So nth derivative of x is 0. 0. Nth derivative of 3 is 0. And for these two we have formula. Now in the sixth problem, it is again 1 upon x plus 1 into x plus 3, partial fractions. Seventh is to be done in the same way. Divide and proceed. Eighth में it is directly partial fractions. It is x upon 1 minus 2x into 1 plus 2x into 3x minus 5. So put x equal to half, x equal to minus half, and x equal to 5 by 3. So these three will get separated. And over here, as the power of the numerator is less than that of denominator, if we can factorize the denominator, sum of the coefficients is 0. So x minus 1 will be factor. So 1, 2, minus 1, minus 2. Synthetic division by 1. So it becomes 1, 2, 1. So it is 3, 2. So it becomes x minus 1 into x square plus 3x plus 2 equal to 0. Is this. So it is x minus 1 into x plus 1 into x plus 2. And go for synthetic division. You don't have to do anything for the numerator. This will be simply x square plus 4x plus 1 upon x minus 1 into x plus 1 into x plus 2. And then that can be directly written as numerator of x minus 1, put x equal to 1 everywhere except this. So it is 1 plus 4 plus 1 upon 1 plus 1 into 1 plus 2 plus x plus 1's numerator x equal to minus 1. So it is 1 minus 4 plus 1 upon minus 1 into minus 1 plus 2 plus numerator of x minus 2, x plus 2, x equal to minus 2. So 4 minus 8 plus 1 upon minus 2 minus 1 into minus 2 plus 1 and formula. So this is here. This is the previous one. So in a way these problems are easy. So have you noted down the problems? You can do them later. Or you want to do them right now? Done? Now the next type of problems are on the similar lines, but next set of problems is find nth derivative of 1 upon x square plus a square. Number 2, x upon x square plus a square. Number 3, tan inverse x upon a. Number 4, it will be tan inverse root of 1 plus x square minus 1 upon x. Then it will be cos inverse x minus 1 upon x plus 1 upon x, and 1 upon 1 plus x square plus x cube. And we don't have any formula for any one of them, right? But first one can be written as, if you observe, x square equal to minus a square, so x equal to plus or minus ia. We have studied complex. So this can be factorized as x minus ai into x plus ai. And we can go for partial fractions also. So it is something upon x minus ai plus it will be something upon x plus ai. So numerator of x minus ai, it will be 1 upon 2ai. Put x equal to minus ai, it will be 1 upon minus 2ai. So this will turn out to be simply equal to 1 upon 2ai into bracket 1 upon x minus ai plus minus 1 upon x plus ai. Now can we find nth derivative of this? We can. And then nth derivative of 1 upon x square plus a square will be 1 upon 2ai, that will remain. Nth derivative of this, it is 1 upon ax plus b, but b in this case is ai. So minus 1 raised to n into n factorial into 1 raised to n upon x minus ai raised to n plus 1, and this will be again minus 1 raised to n factorial 1 raised to n upon x plus ai raised to n plus 1, which we can take it further as minus 1 raised to n taken common, n factorial taken common upon 2ai. Now what should we do? it remains as 1 minus x minus ai raised to n minus 1 upon x plus ai, this is n plus 1 and n plus 1. Now what? Minus 1 raised to n factorial upon 2ai, it will be x plus ai bracket raised to n plus 1 minus x minus ai bracket raised to n plus 1 upon x square plus a square raised to n plus 1. What is numerator? We have studied De Moivre's theorem, right? So these two are conjugates of each other. Subtraction of conjugates will be 2 sine. We already know that cos theta plus I sin theta and cos theta minus I sin theta, when subtracted it will be 2I sin theta, but of course they are going to be with r. So when you subtract, you will get 2I r sin theta. Now for this number, what is r? Root of x square plus a square. What is theta? Tan inverse of a by x. Right? So I can straight away go and write it as minus 1 raised to n factorial upon 2ai. It will be 2I r sine of theta upon x square plus a square bracket raised to n plus 1. Is it okay? What is r sin theta? Anybody? What is r sin theta? I cancels, 2 cancels. What is r sin theta? Here a. Even if you substitute, it will come out to be the same thing. It is the imaginary part, r sin theta, that is a. So r sin theta is a. So your final answer will be minus 1 raised to n factorial. Even that a cancels because it is here, and upon x square plus a square raised to n plus 1. What is the answer given? Has he given the answer? Oh, 1 second. We are making one mistake. It is correct till here. It is correct till here also, but what has happened is n plus 1 we missed. So it is minus 1 raised to n plus 1 and it will be into 2I sine of n plus 1 theta, right? Yeah, this is how it should be, upon x square plus a square raised to n plus 1, where r is root of x square plus a square and theta is tan inverse of a by x. Good enough. Still I cancels, still 2 will cancel, fine. So it is minus 1 raised to n factorial. I will write it here. It becomes minus 1 raised to n factorial upon a into r is what? Root of, rather I will write it as x square plus a square raised to n plus 1 by 2 into sine of n plus 1 tan inverse of a by x upon x square plus a square raised to n plus 1. And we don't have any substitution for this because it will remain in terms of theta. We can put the final answer as minus 1 raised to n factorial upon a into x square plus a square raised to n by 2 into sine of n plus 1, better to keep it as theta, where theta is so and so. That will be the thing. Any clue for the answer? Okay, he got it in a different form. He doesn't have x square plus a square, but he is putting it as again r raised to, why n by 2? It is n plus 1 by 2. N plus 1 by 2. Yeah, this answer is right. He is putting a as again r upon sine theta and making the whole confusion. This is okay. So now why this problem was important? Because in the second case, how are you going to do it? You will have to proceed exactly on the same lines. Partial fractions might change, because you will again start with x upon x plus ai into x minus ai, and when you substitute, it will be minus ai upon minus 2ai upon x plus ai, and it will be plus ai upon 2ai upon x minus ai. Rest of the procedure remains the same. Now minus is with this and plus is this, so only sign difference. If you go with this tan inverse, the first derivative of this y1 will be, what is the derivative? Tan inverse 1 upon 1 plus x upon a bracket square into 1 upon a. That makes it a upon a square or x square plus a square, which is again the first problem. Only thing is, this is first derivative. So when you want to go for nth derivative of this, you will have to use this formula with n equal to n minus 1. So first, second, third, they are all just the same. Things will change from here when you go for tan inverse of this. Is there any formula over here? Can we make any substitution, or should we differentiate and proceed? If you substitute x equal to tan theta, this is 1 plus tan square sec square, that is sec theta. Sec theta minus 1 upon tan theta. So if you cancel, it will be 1 minus cos theta upon sin theta. 1 minus cos theta upon sin theta, half sin square theta, 1 minus cos theta upon sin theta, yeah. 2 sin square theta by 2 upon 2 sin theta by 2 cos theta by 2. That becomes tan theta by 2. That is theta by 2. And what was the substitution? X equal to tan. So it will be half tan inverse of x, and it will proceed with this. So first derivative will, no, that it itself is tan inverse, and you will have to follow this with a equal to 1 or 2, because it becomes tan inverse x by 2 ही आता है वो, half tan inverse. What about this? It will be x square minus 1 upon x square plus 1. X equal to cos theta. This is becoming x square minus 1 upon x square plus 1. But minus sign, how will you adjust? It becomes tan square minus 1 upon tan square plus 1 in that case. Or still, it will still work. It will be minus, this will be sec square, and you will have to multiply by cos square in the numerator. So let me check. It becomes tan square theta minus 1 upon tan square theta plus 1 is sec square theta. So sec square theta, if you multiply by cos square, then it becomes multiply by sin square minus cos square theta. minus of cos 2 theta, so it becomes minus 2 theta or 2 theta. No, both that constant we can adjust, but with theta what will you do? Again it will be tan inverse. So it is again reducing to the same thing. Now what about this? Yeah, take x square common. So 1 plus x square into 1 plus x. So it is 1 plus x square into 1 plus x. Partial fractions for 1 plus x square follow the same thing. So practically all the 5 problems are using, 6 problems are using the same thing. Okay. Problem changes, you will have to end up with getting the same thing. Though it is cos inverse, it will still end up with the same substitution. It comes to theta or theta by 2 or 2 theta or pi minus 2 theta, and theta is always tan inverse. Right. So we are just put onto the same rail. Okay. First, second, third, fourth to be done in the same way. Right. And one can probably use this as a direct formula also. First you solve this and then we will proceed with the next. Right. Karo.
थर्ड मध्ये n प्लस 1 टाकणार ना शेवटी n minus 1
In third, you will have to put n minus 1. First derivative comes out to be this. See, what is the question? Find nth derivative. So first derivative is this. Now after this you will have to go for n minus 1 derivative. So इसका nth होगा वो, right? So इसमें n equal to n minus 1 put up करके. And successively ये सब वैसे ही होंगे, because every time we end up with tan inverse, first derivative will be the required, and of that nth minus 1, n minus 1, right? Down the problems लिहून घ्या फक्त. Now I will solve the second one, which is just same as the first one with a little difference. So it is x upon x square plus a square, simplified as x upon x minus ai into x plus ai, right? So by partial fractions we get ai upon 2ai upon x minus ai plus minus ai upon minus 2ai upon x plus ai. So it turns out to be half 1 upon x minus ai minus half 1 upon x plus ai. Minus minus plus, yeah. Both are minus. Addition comes out to be, yeah, x. And so we will have to go for nth derivative of it, right? And so it comes out to be nth derivative of 1 upon x minus ai plus 1 upon x plus ai with half taken outside will be, by formula, half into bracket, it is minus 1 raised to n into n factorial into 1 raised to n upon x minus ai bracket raised to n plus 1 plus minus 1 raised to n into n factorial upon x plus ai bracket raised to n plus 1. Actually problem is over here itself. Only thing is, because the given expression doesn't contain I, rest of the efforts will be just to eliminate that I, right? So I can say that x minus ai and x plus ai are conjugates. So if I say x plus ai is equal to r e raised to I theta, x minus ai will be r e raised to minus I theta, where r is root of x square plus a square and theta is tan inverse of a by x. So it will be minus 1 raised to n into n factorial upon 2 into bracket 1 upon r into e raised to minus I theta raised to n plus 1 plus 1 upon r e raised to I theta raised to n plus 1. Right? So from both of them I can take 2 into r raised to n plus 1 common. It becomes 1 upon e raised to minus I into n plus 1 theta plus 1 upon e raised to I into n plus 1 theta. Right? So this will require less steps than the previous one. This will be faster. And now we don't take LCM, we just revert their powers. So this becomes minus 1 raised to n factorial upon 2 into r raised to n plus 1. It will be e raised to I into n plus 1 theta plus e raised to minus I into n plus 1 theta. So addition of conjugates will be 2 cos, right? So this will be minus 1 raised to n into n factorial upon 2 into r raised to n plus 1 into bracket 2 cos of n plus 1 theta, where 2 will cancel. Right? We will have to get the things back in terms of x, not this r, because that is what will matter, how x has changed the power. So we already have that x is equal to, x is what? R cos theta. X is r cos theta, right? Because here we know that x plus ai is nothing but r cos theta plus ir sin theta. So r can be substituted as x upon cos theta. So this will become minus 1 raised to n factorial, 2 has cancelled, upon x upon cos theta bracket raised to n plus 1 into cos of n plus 1 theta, which will lead to minus 1 raised to n factorial upon x raised to n plus 1, okay, into cos raised to n plus 1 theta into cos of n plus 1 theta will be the required answer. Like in the previous case, it will come in terms of sine. If you observe the previous problem, we already had that 2i here, and there was a subtraction, so it has resulted in 2i. So final answer won't contain I. Okay, so if it is proved that cos raised to n plus 1 theta, then we will have to eliminate that r. Okay, so we are not keeping both of them in the final expression. We are just keeping one of them, and we are getting back x. That is the main thing. Right? Exactly on the same lines, we will have to solve the other one. So the approach can be different. I switched over to r e raised to I theta right at this stage without simplification. Previously what I did, I had taken the LCM, and x minus ai into x plus ai was x square plus a square bracket raised to n plus 1, and that became r square raised to n plus 1 and what not. Okay, this will be better. का नाही अजून का कंटाळलात? सबस्टिट्यूशन करून टॅन इनवर्स पर्यंत तरी या रे, बाकी मग पुढे तेच लिहायचंय. म्हणजे तेच रोज आपलं डॉक्टर सांगतात तसं सांगतो की रोज संध्याकाळी एखाद एक दिवस झोपण्यापूर्वी एक प्रॉब्लेम करा, असं. बाकी काय कारण हेच लिहायचं आहे ना, तर त्या स्टेपला आणणं एवढंच फक्त मेजर काम आहे त्यात. Now we will go for comparatively simple problems. Okay, and again we will have to do one step and leave the some space to solve it further. Okay, and I don't have anything to teach into it. You only can tell me as how these problems are to be solved. Again the title is same, find nth derivative of first one ax plus b upon cx plus d. Second, log of x square plus 3x plus 2. Third, log of ax plus b into cx plus d. So these three. What is there? This one we have already done, 2x plus 3 upon 5x plus 7. Only thing is it is in terms of a and b. So we can very well do it. From these two problems, whenever it is log, the first derivative comes out to be our previous problem of partial fractions. Derivative of this will be 1 upon x square plus 3x plus 2 into 2x plus 3. So y1 comes out to be 2x plus 3 upon x square plus 3x plus 2. Partial fractions, only thing is don't use formula for nth, it will be n minus 1 derivative. Same thing over here, it will be y1 is what? 1 upon ax plus b into cx plus d into, tell me what will be? A into cx plus d plus c into ax plus b. Fine. Or you separate the log. Yeah. It is log a plus log b. So it will be straight away 1 upon ax plus b plus 1 upon, a upon ax plus b plus c upon cx plus d, and apply n minus 1th. Right? So these problems are not something that we should really do. Right? So make a note. This is the only one to be tackled because it is in terms of ABCD, right? Otherwise these are straightforward. And these substitutions, now the next three. Log of x square plus a square. First derivative will be 2x upon x square plus a square, and we have just solved x upon x square plus a square. But over there it was the original problem, so nth derivative. Here after first derivative n minus 1. Which formula? You can. Here no? For this, yeah, you can. Right. Yeah, log of x plus 1 into log of x plus 2 and log of x plus 1 plus log of x plus 2, and directly apply the formula. Yeah, even that will do. Can one think about this problem in a different manner? I am just asking you. Okay, suppose y is equal to ax plus b upon cx plus d. See, though it may not be there in the book. If I take log, it will be log of ax plus b minus log of cx plus d. If I differentiate, it will be 1 upon y, y1 equal to 1 upon ax plus b minus 1 upon a upon minus c upon cx plus d. Now question is, can we find nth derivative of this left hand side? How?
1 upon h plus b square to 1 upon y square.
It is y1 upon y. Because the right hand side is easily solvable now. And the left hand side will create a problem. What will be nth derivative of 1 upon y, y1? And unfortunately, if we go with the cross multiplication, then the problem goes to the next type which we are going to solve from tomorrow, that is Leibniz theorem. Then it becomes product of the two. Okay, then it is to be solved there. So we can't work out in this way. It has to be done in the previous manner only, because the left hand side creates the problem. Right? y1 upon y, we don't have formula for finding nth derivative of it. You can always say it is next derivative will be 1 upon y, y2 minus 1 upon y1, 1 upon y square into y1 square, and it will go on expanding, because every time it is numerator upon denominator. Right? So log of x square plus a square, first derivative, and you can do it. Second problem in this category is, just tell me the substitution. Tan inverse of 2x upon 1 minus x square. X is tan theta. 2 tan theta upon 1 minus tan square theta. Third, tan inverse of 1 plus x upon 1 minus x. X equal to tan theta. X equal to tan theta. 1 plus tan theta upon 1 minus tan theta is tan of pi by 4 plus theta. Right? So they are just checking whether you can do it in that manner. 1 upon x raised to 4 minus a raised to 4. X square minus a square into x square plus a square. And out of that, x square minus a square is x minus a into x plus a. So those can be solved directly. And see, this can be written as 1 upon x square plus a square into x square minus a square. We will temporarily go for partial fractions. X square plus a square, find its numerator. X square minus a square, find its numerator. We can simply say that one is plus and other is minus. This can be adjusted. It is x square plus a square minus, if you do it, it will be, if I this is plus and this is minus, what do we get? We will get it as x square plus x square minus a square minus x square minus a square. So minus 2a square. So this has to be 1 upon minus 2a square. This can be solved by partial fractions. This we have already done. So these are the type of problems which we have, right? Just make a note of this. We'll take a break and then start with planes today. Yesterday we did orthographic, and that dimensioning also is to be studied, right?